7, 8, and 9 are all similar because they have a monomial, so one term on top and two terms in the denominator. So in order to do this, we're going to look at another concept before we get going on this. And that concept is if you take, and I'm going to make this in a simpler form, but if you take a binomial that has a square root in it, so let's just write square root of b, and this will work for these other ones that don't exactly look in this like this form, and you multiply what's called by its conjugate, which is a minus the square root of b. So you change the sign between the two terms. You don't change any other signs. Let me say that again because people mix this up a lot. You change the sign between the two terms. You don't change a sign out here in front of a. If you multiply those together, I'll show the multiplication, although some of you are going to recognize this as something that we did before, but we have a times a is a squared. A times negative root b is negative a root b. Switch colors here. Root b times a is a root b. And root b times root b is root minus root b squared, which ends up being a squared. These become 0 minus root b squared, which actually, it's not the important part, but it equals b. The important part is when you multiply a number by its conjugate, you don't have any square roots left. And that's what we're going to use to help us simplify 7, actually the rest of this page, but right now we'll look at 7 through 9. So what we're going to do here, we can't do any simplifying to start with, so we're going to multiply by a special form of 1. That form of 1 is going to be the conjugate of the denominator. So as I just mentioned, it's going to be the same values in the two terms, so 2 root 3 and 5 root 2, but here we have a minus sign, and what I said is you have to change the sign in between, so this will be a plus sign. So we have 2 root 3 plus 5 root 2, remembering that this whole thing here is just equal to 1 because it's something divided by itself. So now that's all that's left to do is some multiplying. So we distribute this 3, and we have 6 root 3 plus 15 root 2. In the denominator, we have to multiply this whole thing out. The other thing that I should have mentioned up here is when you multiply something by its conjugate, you just end up with the first term squared. See, this is our first term minus the second term. Sorry, I should have come here. First term squared minus the second term squared. So when you multiply conjugates, you only have to do that. And that will really shorten things up. You don't have to do FOIL every time. So we're going to do the first number squared, 2 root 3 squared, minus the second number squared, 5 root 2 squared. So if you need to follow that through your other examples, how to multiply those out, you can always come back to this example or pause. And when you're doing number 8, you could watch number 7 again to realize that you do the first number squared minus the second number squared. And that's when you do the denominator. So we still have 6 root 3 plus 15 root 2. And then we're just simplifying this. So 2 squared is 4. Root 3 squared is just 3. And then minus 5 squared is 25. and root 2 squared is 2. So we have 6 root 3 plus 15 root 2 over, to save room I'm going to do this, this is 12 minus 50. 12 minus 50 is negative 38. The last thing we want to check here to see if we can do any simplifying, and what we do is we look at our coefficients here, the 6, the 15, and the 38, and we think, does any number go into all three of those? And it doesn't. 3 goes into 6 and to 15, but it doesn't go into 38. So our answer is complete as is. So there's our answer. So now you can use the same method as you do number 8 and number 9. Number 8 and number 9 have simpler looking denominators, so they might be a little bit easier. And again, maybe you watch number 7 while you're doing number 8 and you pause as necessary.